So this is a question from autumn 2016, question 3b. A random sample of the lifetimes of 13 bulbs is given below. This is the lifetimes in what? I don't know, hours, days, who knows. Anyway, so 13, n equals 13. The first thing we're going to have to do here is enter these into the calculator. So this is one of the new calculators here. And what am I going to do? I'm going to reset this calculator here now so that everything is as it came out of the box. So I'm going to go shift and where's clear on this? I'm not quite used to these new calculators yet. Where the hell are you? Reset there, shift and reset, I guess. So now initialize all 3 equals for yes and press AC. And now we're ready to go. Now I'm going to press setup, and then I'm going to go statistics, and I'm going to press, what am I going to press? AC, is it, or equals for selecting that, I guess. And now we're going to go single variable, because these variables we just have times, right, lifetimes. We don't have lifetimes matched with anything else. So single variable 1, and now we're ready to enter. Just zoom in on that there. So now we're going to enter, and I'm just going to go 14.7 equals, right? And down along like that. 14.8 equals, and so on. 15.3. Next up is, what's next up? I don't know if you can see that a bit better. That's 15.3. No, that's a better angle now. 15.3. 15.6, press equals, and yeah, so on. I'll zoom in a bit more there. Even a bit more. Right, now, so the data point 5 is 15.2. Now that's gone in. Next up is 13.8. That's gone in. 13.3. Be careful entering these. 12.6, 14.2, oops, 14.2, yeah, it's okay. 14.7, 15.1, and 13.8, and finally we have 12.9. So that's 13 data points entered. Now we can press the on key here, and this comes up on the screen. So to access the summary statistics, we press the option key there. See option OPTN, we press that, and now we have 1, 2 or 3. So I'm going to go with number 2 there. Press 2, and here's our summary statistics. They come up on the screen. Right, and we have sigma x. So sigma x there, that's better now. Sigma x, oh, I lost the screen there now, but sigma x equals, what does it equal? 0.922. And another figure that's noteworthy there. Get it back. I'm going to go down here on my joystick, and we have SX. SX is 0.96. Right, and it all told us that n equals 13. Right, on with X bar. X bar equals 14. What's X bar? 14.31. The 2 decimal places. 14.31. What else? That's about it. So like SX there, that's equivalent in the formula, the exam formulas. That's equivalent to S hat. Okay. And this guy here, So in the formula, sigma x is S. So that's standard deviation, and that's sample standard deviation, S hat. So those are the figures we need. For part 1 then, the formula we're going to use is the mean, the population mean is less than and greater than, in this case it will be x bar plus t, with n minus 1 degrees of freedom, we have s hat over root n, and over here we'll just have the same type of thing except x bar minus t, the same figures really except we have a minus in the middle of them, s hat over root n, and n there is 13. So now we need to get our bits for this formula here, like n minus 1, 1 second now, pens. N minus 1 is going to be 13 minus 1. Once again, n minus 1 is going to be 13 minus 1. So n minus 1 equals 12. So what are we going to look up in the t table? And the t table there is on page 40. It's on page 40 in the logbook. Right, so it's going to be n minus 1. So we're looking up the row 12 degrees of freedom, page 12 or page 40. Now, you see we're told there is a 99% confidence interval. So this is going to be the shape of our distribution, and we'll have a section here and a section there, and this stuff in the middle has to cover 99%. So that leaves a 0.5% for each of these gaps at the side. So 0.05 and 0.05. So the column, we're going to be looking up the row with 12 on the t table, and the column is going to be the downways guy, the column 0.05. So we're it's going to be, well, to be careful there, it's going to be 0.005, half of 1%. Right, so we'll have an extra 0 in here and in here. So 0.005, we look down along that column where it intersects with the row marked 12, we get t 12 degrees of freedom with 0.005 as our column. We get 3.055. So that's going to be our t value on both sides of this guy. We have x bar, that's 14.31. So now we're ready to fill this in. 14.31 minus 3.055 multiplied by s hat, which is 0.96, all over root 13. So our population confidence interval, that will be the lower limit, and the upper limit will be 14.31 plus 3.055 times 0.96 all over root 13. So when we do up the calculations on the left hand side here, we're going to get 13.496 etc. So we can round that say to 2 decimal places, and we end up with 13.50. So population mean is greater than that, and it's going to be less than. We bang this stuff into the calculator, we're going to get, well, let's do it here quickly so I can edit my last calculation and just stick in a plus instead of the minus there, and I put 15.123. 15.123. So round that to 2 decimal places and get 15.12. So we are 99% confident. that the population mean, mean, otherwise known as mu, is between those limits. Between those limits there, which are 13, mu is greater than 13.50 and less than 15.12. We can say that with 99% confidence.